Well, I went down to Blackpool today to measure the height of the actual pier above sea level. So I got that data, but whilst I was there, I saw the Douglas complex that's 15 miles or so outside of Wales. And I thought I'd show you a video of it.
You're up.
Is this with the new camera?
No. I wish it was.
That's due any day, isn't it?
Due any day, yeah. Right, listen, this is when I was in Wales, and I actually filmed the Douglas complex from whilst I was actually in Wales. You can see that it's got this flame that comes out of it. And I kept seeing this smoke every time I went down to Cleveland's in the distance, and I never knew what it was coming from. When I went to Wales and I saw this and I saw the plumes of smoke it was bellowing out, I realised this is what I was actually seeing. So I'll just play the video slightly. You can see the flames on it, etc. And there's the start of the wind turbine. So that was from Wales, and that's the actual wind. Sorry, that's the Douglas complex. I'll show you the video from today that I caught. Where are we? This one. So look at that. Can you see that? That's the Douglas complex. That's the flames coming out of the top of it. Way in the distance, you can see the smoke coming out of it. And I'm zooming back out now from North Pier. So there I was on North Pier, 44 feet above actual sea level at this time, when I was holding it at the rail. Obviously, I'll zoom in again, and I think I'll lose focus on it this time. But essentially, that is the Douglas complex. Would you agree, Nath?
Oh, now I can see it.
I have no idea, but I'll take your word for it. Look at the Google map when you show me.
Flames? Can you not see the flames coming out?
Yeah, I can.
And the smoke.
And I see the smoke. Yes.
Yeah.
But it's already blurred up. It's in mirage.
That looks pretty crazy.
So when I did the curve calcs on it, etc., I went to Google Earth. First thing I did was I got the coordinates for it, which are up here for the Douglas complex. So I plugged them in, put them into Google Earth. I actually got a value of 28.7 miles in distance. Now, because I'd actually gone to just measure the actual height of the pier above sea level at the time, I know exactly what height I was. So there's where it is. There's the Douglas complex there. So I plugged this 208, sorry, going back to the Douglas complex, it also gives you some details about that. That would be up here. It is 54 meters high, or 177 foot high, right? So essentially 177 foot. And when I put all the data in, viewer height, 44 feet, distance 28.7 miles, hidden should have been 282 feet. So hidden should have been 282, and obviously it's only 177 feet high. So we've got 100 feet there that they need to explain to us. Thank you very much. Another one. You guys still there?
Yeah, we're all on mute listening to you, Auntie.
Right, yeah, there you go. So obviously what we've got going on here, we've got this this band of air that is actually stopping us see the bottom of it. You can see that these are fake waves and the sky is being reflected down onto the surface, but fortunately it's high enough that you can actually see the flames coming out of the top of it. But it's a very, very good example of showing you where this this band of blockage is, this 0.5 degree or so or less. When you get to that sort of angle, this is the sort of atmospheric conditions that you bump into, because clearly that isn't sky that's underneath there isn't real sky beneath the flame. It's obviously a reflection of the sky over the water. It's causing the blockage you see in this complex.
So I can only see the flame just right above the water line, it looks like. So I guess my question is, what we're not seeing is 170 feet of the structure itself, so that you would have to somehow figure that into
well, what you can see that this is underneath it. it doesn't go straight down to the ocean, right?
Yeah.
It goes
Yeah.
down
Okay.
to the
Yeah. There's a.
it goes
Yeah.
down to the sky.
Right.
The sky is being reflected down over the ocean, and this mirroring layer clearly builds up over many miles, and that's what forms the blockage.
Yeah, but my point is, okay, so I'm in a pretty extensive discussion with a friend on Facebook, and he repeatedly says that atmospheric obstruction does not block or distort what we see.
Is he a glober?
Yeah.
Well,
yeah.
he's talking out of his arse, obviously.
No, I know, but when I see stuff like this, I just don't get it. It's just mind blowing.
Well, it's like, you know, when I've showed you the buildings of Barrow and they're miraged down on themselves and they look
I
like
know.
they're looming.
I know. I showed him the stuff that I had at only 6 miles, and you had you had boats with no bottoms. I had 2 fishermen standing on nothing, and he in the comment before he said atmospheric distortion doesn't block blah blah blah, and I said, okay, what are these fishermen standing on? And you couldn't see anything between, it was like a quarter of an inch between them and the water. So they're floating on nothing. You know what I mean? It's just crazy. Absolutely mind blowing. Well, what I find mind blowing about that picture you just showed is that you've got 170 feet of missing structure that's obviously obstructed by the atmosphere.
Yeah, it is obstructed by the atmosphere.
Francis, could you show the whole structure again with the flame coming off the top of it?
Sure, yeah. 1 second. 4th of August. It would be this video right at the start. Oh.
Wow, you could really only see the flame coming over the. That's crazy. And how far away was it? Where were you away from it?
28.7 miles. So where my cursor is now essentially would be where the curve calc should be.
Right.
The rest of it's hidden by the atmosphere. As simple as that. It's the watered mirror layer that builds up over and the narrow angle, the narrow viewing angle. So when you get down to like 0.5 degrees or under, you're going to see this effect that it starts to block things out from the bottom up.
So, because even if that was actual curvature, there's no way you should be able to see the flame because it would be tilting away and leaning away from us. Like, that's just crazy.
This is an image that I snapped today. The top one is the image that I took today. The bottom one was 18 miles or so from sea level, essentially, when I went at night time and I filmed. Obviously, this part at the bottom, hang on, I might be able to show you on this image, actually. This is the image that I took today. There we go. So obviously, this is the pier that's in the way. This is blockage. This stuff in front is a pier that runs in front of my line of sight towards the big one. So when I superimpose my line of sight over what I actually captured, what do you know? And also, can you see the difference in the texture of the darkness down at the bottom? You've got really black at the bottom, and you've got a lighter black here that's sort of blockage, but it's not lit up. You can definitely tell that. That would be the pier that's in the way. That would be this pier that's in the way here. So all this is what we saw. And the curve calcs, again, if I put the curve calc in it, let's do a bit of a line, do it in red. So curve calcs would say this is where the curve calc should be.
Yeah, they'll ignore the red line. They'll ignore the red line because that's where the curve should be. They'll look at the obstruction at the bottom and say, well, that's obviously the obstruction caused by curvature. Any obstruction's curvature, right?
But it's not. What this is, from there down to there is the pier that's in the way on this image. You see this pier that's in the way here, this pier, that there, that pier's in the way. I don't know if you can make that out. Let me increase the size so you can see it. Yeah, so this is the pier that's in the way, the line of sight. Yeah, that we're actually seeing in the image down at the bottom here. And then obviously all of this is visible. And again, curve calcs would have put it about here. That's all I should have seen when I went to Barrow over the weekend. But yet we saw all of it down to the bottom. We saw the concert and everything that was going on. So this is him with his theodolite, and he said that he took this image from, he gives some details of his location, the equipment that he used, etc., and he shows this image, right? And he's obviously saying that the green line is where the flat horizon would be if he was on a flat Earth. The red line, the blue line, they're different, you know, for the curved Earth and etc. But this is the only evidence that he provides. This is it in its entirety. He doesn't show the video, the image being taken. He doesn't show any video footage. He just presents this image with the crosshairs in, right? Now, anybody could do this. Literally, you could put a crosshair anywhere in this image. Am I right, Nathan? And say this is what it should be.
Not exactly the most... It's not like what you do, let's put it that way.
And I called him out on it. And I said, I'm sorry, but I can't look at this critically and say, well, how can I validate that this image was taken exactly how you say it was? There's nothing that says that this is an accurate representation of what you did.
It's unfortunate. Sorry to interrupt. It's unfortunate for Ruhif because a year ago, this was the standard that we presented, and what you got was the same exact criticisms you're now giving him from ballers. So flat earthers would present this and go, look, this proves it's flat. And they go, well, how can we even accept it? We don't know where you are. You haven't given us the barometric pressure. You've not given us your altitude. You've not shown us GPS locations. You've not twiddled the camera around to prove that's where you really are. And at the time, I remember you doing it, Auntie, going, what? It's just a photo. Why do I need all that stuff? Now, tables have turned. It's like, no, this isn't the standard, Ruhif, I'm sorry. A year ago, you might have got, well, you probably wouldn't have got away with it on our side. You might have got away with it on your side, but no, not anymore.
Well, I can reverse it. I can reverse this on him. He's essentially saying that he's gone out and he's took this image, and what do you know? It absolutely 100% conforms to the ball model, yeah? Not even close to being the flat Earth. It's the ball. This is the ball Earth prediction, and this is what he went out and he filmed it, and this is his evidence. Yeah, one image with some crosshairs in between it.
Can I?
Sorry, go on.
Yeah, I was just reminded of this image of my criticism, and that is this: the green line is the flat Earth prediction. But that would require the object to be much closer and larger. Ridiculous.
Yeah, I was going to get on to the perspective aspects of it, but well segued. Exactly.
Yeah, I never thought of that as well, actually. Yeah, he has omitted perspective as per usual. We can flip this around, though, and we can look at things like... Let me just move that out of the way. So if he was to ask me to do a prediction, this is obviously the image that I took, and I'll just get rid of all these lines, right? So on this image here, if I was to ask to give a prediction of what I would have seen or what he would have seen, and he was to give a prediction, this is what he would have done. He would have said, well, this, where this red line is now, this is what's going into this is the ball Earth model right there. That's the ball Earth model. That's what I expect to see. If you go to Barrow and you look over at Blackpool, you will only see this portion of the top of the big one. That's what the ball Earth model would be. So I can flip it back on him and say, well, do you know what? I did this in a video, right? I did this in a video, and look at the comparison. It's not even close. You know, we're seeing all of the big one, literally all of the big one. And how does that conform to his ball Earth model? You know, this is a video, not just a still image that he's put some crosshairs on. This is actual footage, actual video photography, where we can compare like for like. You know, flipping it back, what would he predict? He would predict that this is where the curve would be. So I don't understand what his challenge is, really, to be fair. You know, he knows I will go out and I'll just crush him with it.
okay, let me say this. So that red line, Ranty, is a you're just making that up per se, right? That's going to be the curve.
The top of the entire building is 227 feet tall. Essentially, I think there should be 98 feet of curvature. Sorry, you should only see 98 feet of the top of it. So putting this line in, roughly 98 feet of the top is what we would see on the curve calcs. This is what the curve calcs would say.
According to the curve calcs.
For the whole Earth.
So
yeah,
if you exclude perspective and only take an orthographic account of the world, therefore maintaining actual sizes of things in their feet and inches value, then it would be that. But presumably, when Ruhif's making his comparison, telling us where horizon, he's not factored in any perspective whatsoever into that. And he'll just say, no, I don't need to. His answer will be, I don't need to. I guarantee it.
Yeah, but the problem is that we're looking at something that's still at 90 degrees. So it's not only the fact that there's that much missing, is that the top would be angling away and the angular resolution would be, or the angular measurement the top would be angling away from us. So it would be diminished even then too.
Absolutely.
But we're not. We're looking at something 90 degrees straight up and down.
Yeah, so the one in the top is much closer. So therefore you have a considerably wider viewing angle. The angular resolution of this roller coaster in the top image is vastly bigger than the half a degree that Ranty has caught it in the bottom image. So there is a viewing angle reduction. What's another word for that? Oh, perspective. That would be it. That's not accounted for when they beg the question. When they just assume that they're on a sphere with the curve calculator. Clue is in the title, people. It begs the question. It just assumes you're on a curve to begin with. It's useless. Begging the question fallacy. Perspective omitting curve calc. Anyway, it doesn't account for viewing angle. It doesn't account for perspective.
One other thing I want to say is that also during the day you get things like this. This is a video that I took today. We get this doubling back underneath. You can see it mirroring down on itself. Let me just get it so that we can see. There's the Walney Lighthouse. Now this is off the pier again, 44 feet in elevation. But watch when you come to the buildings of Barrow. Again, they're all doubled down on themselves. You can see when we get to the end of the mountain, I focus on that for a bit, and this is where you can really see how it doubles back on itself. I pause it right there. You know that the mountain itself, it is going on. It is carrying on. It goes further down here, but it is completely being mirrored. The sky is being mirrored back on itself. So this is the refraction line through the entire area. This is all atmosphere. This is essentially atmosphere, because this sky doesn't live on this mountain, right? This mountain in the background is real and solid. This sky is clearly an optical effect that's being miraged in front of it, essentially blocking the bottom of this mountain out. We can't see it because the sky's in the way. Well, how can the sky be in the way when the sky's above it? Well, in this image and the video, the sky's below it. So it is causing blockage. This what we're seeing here, this sky, is effectively blocking out the mountain behind it.
Or you've got one major cliff.
Yeah. There's been a load of erosion.
So, you know, I mean, you can't have the sky. How can you have the sky in front of the mountain? The mountain is behind, you know, what you've seen how many times I've gone down and filmed this mountain, right? We see it trails off and it's actually got land that goes all the way across. Now I'm at a 44-foot elevation here. I've filmed it from an inch, right? And I've seen it all. Now we're at 44 feet, and look at the blockage. Just different atmosphere, different weather conditions. And this mountain and this land that does go along here is completely blocked off by the miraging sky that's being miraged in the atmosphere. So anything that would be on this mountain, where my cursor is now, anything along this line, right, would be blocked out by the sky being miraged down on it. And in this case, or when you come over here, it's actually the mountain that's being miraged back down on itself. And that's where when we go further back, we look at the buildings, and the buildings are being miraged back down on themselves. That's why we've got this doubling effect here. So we wouldn't see the bottom of it because it's the atmosphere that's creating this miraging effect.
Coupled with Airy's diffraction, a limitation of the viewing angle, which would be pretty consistent, but I think in this instance, yeah, you're right. Because we had this conversation a couple of days ago, and I was like, stop calling it atmospherics. It's Airy's diffraction that we're looking at. But lo and behold, you go out and pick one that's going to be that's going to piss all over my bonfire. Well done, Ranty. You got your way in the end. But yeah, Airy's diffraction is still part and parcel of what's going on here. You do have a narrowing of the viewing angle down to nothing. So that will always be the case.
The other thing to point out is there is already a challenge on the table. So before Ruif challenges Ranty to do something, when he's already done something and there already is something on the table, perhaps Ruif should come back with the answer to Ranty for why it is we can see the streetlights from 20 miles away if the Pontchartrain nonsense video that shows that we're supposed to be curved is true. Because Ranty should validate that, and he didn't. He failed to validate the Pontchartrain observation. So why is that?
Well, here's something that's interesting. Now, the Plain Truth asked before, he said when he saw the flames of that thing in the distance, the complex in the distance, right? He said, how come we don't see the bottom of it? Yeah, but we see the flames. Well, if you look at this and you predict, okay, anything that's below this, you're not going to see it because it's being blocked by the atmosphere. But the flames, so essentially the flames that are like 200 feet tall, start at 200 feet or essentially that height, you can see them because they're above the refraction zone. So it's not being miraged down on itself. So anything that's in that zone is going to be hidden, the same as the complex. I might show you that video. We'll have it.
Diffraction zone.
So it's the same here. So when we look at this image, I'm just going to pause it there. And you can see the flames, but can you also see the sky underneath it? It's exactly the same. The sky underneath it is the blockage. It's the atmosphere that's blocking out that complex. Forget the fact that we shouldn't even see the flames anyway, because they should be long gone behind the curve calcs, right? The actual blockage is the atmosphere, the narrowing of the angle that's causing this mirage in this mirroring layer to repeat the sky, essentially blocking out that entire oil rig. The same as the mountain. It's exactly the same as the mountain. So that's what I just wanted to show you anyway.
Thank you, Ranty. Awesome as ever.